Hey everyone, I wanted to do an example also of a homework problem in section 11.10. So this one is asking you to use the definition of a Taylor series in order to find the first four non-zero terms for the function. So when you see use the definition, you really want to make sure that you're not using a known series. So use the definition of a Taylor series. So pay attention to the wording, right? Is it asking you to use a known series to find something, or is it asking you to use the definition? So those are the two different types of things that you'll be asked to do. Here we want to use the definition. So what is the definition? The definition is that f of x is equal to, this is what I talk about in class, the blank, right? Plus blank x minus a plus blank x minus a squared over 2 factorial and so on. And what are the blanks? And the blanks are our function values, right? So in this case, because we're not at zero, it's not a Maclaurin series, it's a Taylor series, it's going to be centered at A. So each corresponding derivative evaluated at the center. So in our case, we're going to see that it's centered at 2. So our function 7 over 1 plus x is going to look like blank plus, so in this case, this is going to be f of 2. Well, let me come back and fill in the blanks. So it's going to be blank plus blank x minus a. Well, a is 2, so it'll be x minus 2 squared plus blank x minus 2 cubed. I went out of order, didn't I? To the 1, to the second, over 2 factorial, and so on. So with zeros, the first power, second power, and so on forever. So what are the blanks? So our first blank is going to be f of 2, then f prime of 2, then f double prime of 2, and so on until you get to the nth derivative evaluated at 2. Now in this case, we're only going to the first 4 non-zero terms. I'm going to do it in general just to do the full example, but technically for your homework, you will start after the first 4 non-zero terms. So it's not the first 4 terms, right? It's the first 4 non-zero terms. All right, so then I'm going to start taking derivatives because in order to fill in my blanks, I need derivatives. So I know that f of x is 7 over 1 plus x, and we're going to be evaluating it at x equals 2, our center. So let me rewrite it as, since I know I'm going to have to take the derivative, to the minus 1. So evaluating it at 2, what do I get? So when I evaluate it at 2, this is 7 times 1 plus 2 to the negative 1, which is really 7/3, right? This is 3 to the minus 1, which is really 1/3. F prime of x is, bring the exponent down, so minus 7 times, and if you're trying to, since I'm going to do the full example, if you're trying to then find a pattern, you're not going to do the math, right? So this will be plus 1 plus x to the negative 2. There's no chain rule here because the derivative of 1 plus x is just 1. So then evaluate it at 2. So this will be negative 7/9. The third derivative evaluated at 2. So let's find, and I'm just kidding, the second derivative. F of x, f prime of x, f double prime. So now bring the exponent down. So it's minus 2 times minus 1 times 7. In this case, we're just going to the first 4 non-zero terms in your homework, but let's find the pattern just to get practice with that. So 1 plus x to the negative 3, right? You subtract 1 from the exponent. So when you evaluate it, now this is going to be negative times a negative is positive. So I do the math to find my actual term. So what is that? 14 times 3 to the negative 3. So which is 1 over 27. So 14 over 27. And third derivative. bring the exponent down, so negative 3 times minus 2 times minus 1 times 7, 1 plus x to the negative 4. And if you see a pattern, you can keep going to the nth one, right? So here, let's notice that all of these are non-zero. So for the homework, we would be done, right? In this case, what's the next one? So it will be negative times a negative times a negative. So that's going to be negative. And then what is that? 6 times 7, so 42. And then 1 plus x, so 1 plus 2 to the negative 4. So that will be 3 to the negative 4, so it will be negative 42 over 81. So that's our fourth term. But if you keep going, do you see a pattern already? Well, could you say what the nth derivative is? And so the way that we do it, let's see. The pattern is if you're taking the first derivative, you have one negative. You're taking the second derivative, you have two negatives, and it's now 2 times 1. When you're taking the third derivative, you have 1, 2, 3 negatives, and you have 3 times 2 times 1, which looks like a factorial, right? So notice that if you went the fourth derivative, you will have a negative 4 times a negative 3 times a negative 2 times a negative 1 times the 7, and then 1 plus x to the negative 5. So when it's the fourth derivative, you will have 1, 2, 3, 4 negatives, and you have 4 times 3 times 2 times 1. So the nth power is matching the factorial and the number of negatives. So this will be negative 1 to the n times n factorial, right? Notice when I'm taking the fourth derivative, 1, 2, 3, 4 negatives. Third derivative, 1, 2, 3 negatives. So nth derivative, I'm going to have n negatives. Going back to the numbers, fourth derivative, I have 4 times 3 times 2 times 1, which is a 4 factorial. Third derivative, 3 factorial. Second derivative, 2 factorial. So nth derivative is going to be n factorial times 7 times 1 plus x to the negative what? And you go back to the pattern. This is why it's nice to not do the math, because then I can see, okay, let's go back from the beginning. When it's the first derivative, I have a minus 2 there. When it's the second derivative, I have minus 3. When it's the third derivative, I have minus 4. Fourth derivative, I have minus 5. So if I have the nth derivative, this is going to be a minus n plus 1, right? That's one more than the number of derivative that I'm taking. So when you evaluate it at 2, this will be negative 1 to the n factorial times 7 times 1 plus 2 to the negative n plus 1, so which is 3 to the n plus 1. All right, so now we can write out what our Taylor series for this function is. So what was our function? 7 over 1 plus x at x equals 2, at a equals 2, the center. So this will be, let's go back to our blank, right? So we had f of 2, f prime of 2, and so on. So f of 2, so let me write it out. So it'll be f of 2 plus f prime of 2 times x minus 2, right? Plus f double prime of 2 times x minus 2 squared over 2 factorial plus third derivative evaluated at 2, x minus 2 cubed over 3 factorial plus the fourth derivative, 1, 2, 3, 4. I guess we could stop there. We wanted the first 4 non-zero terms, but for this, I'm going full on out as if it was asking me to find the whole Taylor series. So then this will be the nth derivative evaluated at 2 times x minus 2 to the n over n factorial. And that's a 2 there. All right, so let's plug everything in. So that means that 7 over 1 plus x will be f of 2. What did we get for f of 2? We got 7/3. So it's 7/3 plus f prime of 2. Well, f prime of 2 was negative, so minus 7/9 x minus 2 plus the second derivative. Second derivative, we got positive 14 over 27, so it'll be plus 14 over 27, x minus 2 squared over 2 factorial, and then the third derivative was negative, what was it, negative 42 over 81, x minus 2 cubed over 3 factorial. So this will be 1, 2, 3, the first 4 non-zero terms. So your homework, you would end there, but for our case, this would be, now we put in our pattern, right? If we were asked to find the full Taylor series, then this will be minus 1 to the n, n factorial times 7. I could write it a little bit better. And then 3 to the negative n plus 1. So we can put that as a denominator, and then x minus 2 to the n over n factorial. So for your homework, this is your answer, the first 4 non-zero terms. But if we were asked to find the full Taylor series, then I would say 7 over 1 plus x is equal to the summation of n equals 0 to infinity, right? We do have a first term, so it does start at n equals 0, and then this pattern. So it'll be minus 1 to the n. I'm going to write the 7 first. Times 7 times, then I have n factorial times, and then my 3, I guess it will be over 7 over 3 to the n plus 1, right? It was 3 to the negative quantity n plus 1, and then times your x minus a to the n over n factorial. And so this will be the full Taylor series. Versus what your homework was asking was just for the first 4 non-zero terms. But so again, to emphasize, when you're looking for the pattern to be able to write the full Taylor series, then you need to start taking derivatives, and my advice is don't do the math. Right? Don't multiply as you bring those exponents down, don't multiply things out, because not multiplying it out is easier to see the pattern. Once you're actually evaluating it, plugging in the center, in this case x equals 2, then yeah, go ahead and do the math to find what the actual coefficient is. But when we're looking for that nth term, right, the pattern, it is easier to see the pattern when you don't do the math. Hopefully that helps explain it. And the one other thing, right, pay attention to the wording. This one says use the definition of a Taylor series versus if you're asked to use a known power series to find something. When it says use the definition, that means this, right, or blanks with the x minus a to the n over n factorial. All right, hopefully this is helpful. Email me if you have any questions, and of course we'll review in class as well.